So we are on lesson 6 today, and we're going to start with the lesson. It's called Exploring Angles Part 1, and as usual we're going to start with some vocabulary words. Some of these, like the first one, you've heard before. The first word is ray. An array is a geometrical figure that has one endpoint, which we call the initial point, and the ray extends indefinitely in one direction. So that you've got here the drawing of a ray. You'll see the end point, or the starting point, or the initial point is point B. Notice that there's nothing to the left of point B on this figure. However, the ray extends to the right in an infinite distance, infinitely to this right, and you can see that that is expressed as this arrow on the right side. So when we write the notation for a ray, we always put the end point or the initial point first, in this case B, and then we can put any other point that's on the ray. So for example, we could write BC and then we put a horizontal line with an arrow pointing to the right to indicate that it's going infinitely in one direction. So this could be called ray BC. It could also be written as ray BD. Let's take a look at another type of array. Let's say I have this, and I have point X, and I have point Y here. What would be the notation for this ray? When I ask a question like that, what you should do is you should close the video, freeze the video, and then try to answer the question yourself. And then come back, turn the video back on, and see if you're correct or not. Okay, the correct notation for a ray like this would be XY with an arrow pointing to the right over the XY. Let's go to the next vocabulary word. Opposite rays. Opposite rays are defined as two rays that are collinear. Okay, both rays lie on the same line, and they share only one point in common. So that in this case, we've got two rays which share only point T in common. These rays are TR and TW. Okay, so ray TR and TW. So let me first write ray TR. So ray TR is this ray here, T and R. Okay, and ray TW is this ray here, T and W. Okay, and we call them collinear. They're in a straight line. Okay, good. Let's go on to the next word. We're going to be meeting angles today. Angles. Okay, so an angle is what is formed by two non-collinear rays with a common endpoint. Okay, so let's take a look at this diagram here. What we see here is we see two rays without a common with a common endpoint, but they are non-collinear. So what are these two rays? Well, one ray, well, first of all, what is the endpoint? The endpoint is C. This is also called the vertex of an angle. We're going to see that word in a few moments, but just sort of be introduced to that concept now, vertex of the angle. And our two rays, so what are the two rays that form this angle? Are ray CA, okay, as well as ray CB. So CA is one of the sides of the angle, and CB is another side of the angle. But when we talk about the angle as a whole, we name it like this, angle ACB. The way this name is created is that the middle letter, in this case C, is the same as the vertex. Okay, it is the place essentially where the angle makes a bend, sort of like an elbow. It is sort of like the elbow joint of the angle. Okay, it is where we have the common endpoint of both of the rays. That would be C. So C is in the middle. And then the first letter is a point on one of the rays, and the third letter, B, is a point on the other one of the rays. So ACB is a point on this ray, followed by the vertex, followed by a point on the other ray. Okay, in this particular case, we have another name we can call this angle, and that is angle 1, because we have a little number 1 that is sitting right inside the angle. Okay, so we can say that this is also angle 1. Okay, either of those names are fine. So let's review some vocabulary that we've sort of used in a way already. Sides of an angle. Okay, we've already made reference to this. Those are the two rays that form the angle. This is a different angle. What would we call this angle if we were naming it? You might want to freeze the video and try to name it yourself. Okay, so the angle here could be called angle EFG because F, the middle point here, is the vertex of this angle, and E and G are points on the rays. Or you could name it GFE. Either name is fine. So what are the two rays, though, that form this angle? What are the sides of this angle? Well, that would be, and again, you should freeze the video and try to answer that question yourself first. But the answer is going to be FE, ray FE, as well as ray FG. Those are the two rays that form the sides of this angle. The vertex of the angle. Well, the vertex of the angle is defined as the common endpoint of the two rays that form the angle. And we've already more or less said in other ways that that would be point T here. Okay, so in this case, T is the vertex of the angle. Now let's talk about some other concepts related to angles. We have the interior point of an angle and the exterior point of an angle. So let's take a look at each of these in turn. The interior point of an angle is the point between the two sides of the angle. So let's take a bigger look at this. We've got ourselves an angle, and you can see that the interior point, which is this big dot, lies between the two rays that form the sides of the angle. So here's a couple of quizzes for you. Is this an interior point or not? Yes, it is. Okay, it is between the two sides. Let's give another question that you should try to do and freeze the video. Is that point with a little arrow an interior point? Yes, it is. It is also between the two sides. Okay, I've got yet another question to ask you. Let's take a look at this angle. Is that point an interior point, the point out over here? The answer is yes. It is an interior point, but you might say, well, it doesn't look like it's between these two, but you've got to remember, these go on forever. Okay, we're just drawing them with a finite length because of the piece of paper. When you realize they go on forever, yes, this point is definitely between the two sides of the angle. Okay, so let's go on to the next concept, which is the exterior point of an angle. That's a point not between the two sides of the angle. So let me ask you some more questions. Is this point up here, with that little arrow that I just drew, is that an exterior point for this angle? The answer is no. It's an interior point because, once again, we extend the two sides. And when we do, we find out that this is actually between them. Okay, let's try another question. Is this over there, that little point I just made a little arrow on, is that an exterior point of an angle? Yes, it is. If I extend these two sides of the angle, then everything in here would be an interior point, but everything that's not an interior point is an exterior point. Okay, so let's go on to a few other vocabulary words. Degree of an angle. Well, those are just the units that measure the size of the angle. Okay, so angles have sizes, and we're going to talk a little bit about the sizes of an angle, and that really has to do with the distance, in a way, between the two sides of the angle. So the Degree of the angle has something to do with what's between these two sides of an angle. And we'll get a little bit more specific now. An acute angle is an angle whose measure is between 0 and 90, and this is what an acute angle looks like. It's an angle where we've got the two sides, and they're pretty close together, but they're less than what we're going to see is a right angle. Okay, so I'll do right angle next, and right angle is over here. I'm going to skip down a bit. A right angle is an angle whose measure is 90 degrees. Okay, and that's often indicated by a box that is placed right next to the vertex of the angle over here. Now, the best way to describe a right angle is that that's an angle that is, you may have learned about perpendicular lines. I'll give you a great example of a right angle. That would be the angle between the x-axis and the y-axis. Okay, the angle between the x-axis and the y-axis, and I think I want to draw this a little bit better so that we've got a really good drawing to work with. One line is purely vertical, going straight up and down, okay, and one other line, gee, I think I could do even better than that. Let's do this again. Okay, one angle is perfectly vertical, going up and down, and one angle is perfectly horizontal, going left to right. And that is an example of a right angle. For example, you have one vertical line like the y-axis and one horizontal line like the x-axis, and we would call those perpendicular. They're pointing in perpendicular directions. Now, if this angle were on a tilt like this, it would still be right angle or perpendicular angle. Okay, so as long as it could be essentially rotated back to something like the x and y axis, which are at right angles to each other, it would be a right angle. So I will continue this lesson on the next video.